Okay, here we are. As I said last week that, or the last class, that we were going to start today with theories, but I was wrong. In fact, we have to do something before we start with theories. Okay? You understand that a theory tells you what a person's like. It should, a good theory. Therefore, the best way to have a person develop, how a person learns, and it should, from that, give you some very good ideas about the best techniques for getting the person to learn. Okay, but we are overwhelmed in education with an a-theoretical approach. Let's go to this notebook, whatever you call this thing. It used to be an overhead. I did something bad here. What did I do bad? Hit the pen. Thank you. Okay, the word a means, the prefix a means not, right? Like atheist means, a theist is someone who believes in God, and atheist is someone who doesn't believe in God. Okay? Amoral. Okay? So you can make a moral decision. Even though I want that coat, I'm not going to pull a gun on the store owner and steal it. You can make an immoral decision. I'm going to pull a gun and steal it. But whether I wear blue socks or green socks today is an amoral decision. It has nothing to do with morality, right? So a-theoretical means something that has nothing to do with theory. Okay? Okay, come back to me. So we're going to talk about that today, an a-theoretical approach that has overwhelmed our system. And I'm going to show it to you. Here it is. See as close you can get to me. How close can you get? There it is. The WISC. IQ tests, testing and standardized testing. But before we do that, time for another English lesson. Look, I know I'm a little weird about this, but if you're going to teach, you ought to be able to teach using proper English. Okay. How many people are sure when to use the word who and when to use the word whom? You're sure? Tell me how you know. Do you have a trick? Okay, here's the answer. Okay, I'll give you a grammar answer. Who is the nominative case, is nominative, and whom is objective? Huh? Okay, so you'd use who when you'd use he, two words that end with a vowel, and you use whom when you'd use him. Those two that end in M, or her, but whom and him work out nicely. Okay? So would you say, whom are you going with, or who are you going with? You're going with him. So you'd say whom. Actually, you should say with whom are you going, but that's a different story. Shouldn't add a sentence and a preposition. Okay? Who is in the car or whom is in the car? That one just sounds crazy. Who is in the car because he is in the car. Got it? Should use those correctly. Used to be a television show, Who Do You Trust? No, it's whom do you trust? You trust him. There must have been 8,000 English teachers who wrote in saying, this is wrong. Anyway, didn't last too long, so it's a long time ago. All right, so now you know whom or him. Question on the test. Okay, let's talk about a-theoretical positions, okay? As I said before, as I said before, the psychology as a science is going to tell you, look, if you are going to, if we're going to be a science, we're going to use the scientific method to try to understand what's going on with people. How they think, how they feel, how they learn, etc. How they develop, how their thinking comes about, how their thinking develops and changes, how they form opinions, etc. And psychologists deal with that, right? This was the idea. Okay? As I believe I said before, this is not the only way to get insight into human beings, right? Literature and art give us insight into human beings, but it's one way. Psychologists came along, the social scientists came along and said, maybe we can use the scientific method to gain insights. Okay? But there's a long history of psychology that is atheoretical, that doesn't have theory. Okay? And as a matter of fact, we can almost trace what I call the great divide in psychology. Right? The theoretical versus the non-theoretical. To a man named, here, let's go to the, to a man named, let me erase this. This is such smooth television, isn't it? A man named Binet. Anybody know French? I don't think there's an accent on any of those letters, is there? Binet. Alfred Binet. Okay? Okay? And the people who worked with Binet actually probably created the first Great Divide. Okay, come back to me. Now, Binet was commissioned by the French government, or the government of Paris, I can't remember which one, and I'm too lazy to look, but I believe it was the French government that said, look, they had a different approach from the approach we have today. Approach today is that everyone is entitled to schooling, but in those days, right, they had a different approach, which was, look, school is only for those who can do well in school, can handle school. If you can't handle school, go do something else. And it's only very recently in history that we've had this idea that you have to have an education to get a job. It absolutely stuns me, I must tell you. They're looking for someone, a company is looking for someone who can sell insurance. And in the ad they say, high school diploma or GED required. Right? Why? Why? I don't get it. If there's a person sitting over there who could sell 10 times more insurance than your best salesperson, what do you care if the person has a GED or not? I even saw ads like that for garage mechanics. What do you care? You can fix the car, great, but I don't want you around here because you don't have a GED. What is that? Ridiculous? We really have a diplomatizing of America, if you will. Okay. Most of the people who were reporters, right, for newspapers didn't go to college. They learned the job. They learned the trade on the job. They went around and they wrote newspapers, right? Now everybody has to have a college diploma as newspapers are sort of going into the ground. Of course, it's not their fault. It's all kinds of alternative ways to get the news. But it's, you know, it's just not clear why. But but that's how it is. But in France and in the world in those days, it wasn't that way. School was for people who could handle school, and you sort of went as far as you could, and then when you couldn't, you dropped out and you got a job. My father still remembers how deliriously happy his mother was when each one of her kids graduated what they called junior high school in those days. Now in Texas we call it middle school, right? And then how happy she was, because a lot of kids didn't. And how delighted she was when they all graduated high school, right? It was just wonderful. And she even had two who went to college. My uncle went to pharmacy school, and my father went to a 2-year college to become a photographer. Oh, wow, was she proud of them. And everyone had post-high school training, so two of my aunts took voice lessons. And one learned how to run a machine called a comptometer. Don't ask. It does something computers do today without any troubles. Okay, but it was, you know, but she knew very well if they had dropped out at any point, they could have gone and gotten a job. So Binet's So the French government said, look, what we want to do is find out right from the beginning who can benefit from school and who cannot. Or at least along the way know. So if you've got a fourth grade kid who doesn't belong there, right, you probably ought to say, you know, why don't you leave and go and apprentice somewhere, or go back home and, you know, help your mother cook or your father into whatever your father does, and eventually when you grow up you'll do that, rather than waiting for them not to graduate. So what they asked Binet to do, and they gave him money to do it, was to design a series of tests in which he could test children, and from the tests determine whether the children were benefiting from school, okay, whether they were benefiting from school, and give them a yes or no decision to say, look, these are the kids just aren't benefiting. It doesn't pay to waste money educating them. A yes-no decision. This was Binet's job, and as I said, they gave him money to do it. So it wasn't just a matter of cooking it up off the top of his head. They gave him money to actually go into the field and test if he needed to, this is very important. So okay, I'm giving all of you this job. You got to sit around and you got to figure it out, and you got to sort of come back with something that sounds reasonable to me, since I'm the government official who's going to give you the money, or something that's reasonable to you. So what would you do? You're going to test a bunch of kids, and you're going to decide, are these kids, and it's kids in all the grades, let's say, are these kids benefiting from school, or is it just a waste of time? And by the way, it's possible that the kid is benefiting the first grade, the fourth grade, the fifth grade. By the time the kid is older, 6 years old, so by the time he gets 11 years old, 12 years old, 13 years old, you say, you know, the kid's peaked out, not benefiting. So what would you do? You can't be wrong here. I don't like what Binet did, or what was done with what he did, so you can't get me upset. What would you do? What strategy would you use to decide if a whole bunch of kids, let's say, if a whole bunch of kids, right, kids were benefiting from school, if they were learning anything, if they were doing anything, if they were learning what was going on in school? Come on, somebody can come up with a strategy. You're going to college, aren't you? Come on. You all got into this prestigious university. What would you do? Okay, go ahead. Tell us your name.
Daniel, can you repeat the question?
Yeah. I'm giving you the job to develop a test to decide how well a kid is doing in school, and whether the kid's doing, and to identify the kids who just clearly are not benefiting from school. They're so low, right, that they can't, there's no point in their continuing school. Okay, go ahead. Tell us your name. Push down the button.
Dane.
Go ahead, James.
Urinalysis.
Urinalysis?
Pretty good test.
Okay, pretty good test. Okay. So if you're on drugs, you're probably not going to do too well. He's right, by the way. I worked for years in a private clinic. I had one guy. He had been a heroin addict. He was in his early 20s since he was probably 13, 14. He was finally in recovery, but he couldn't remember. He could remember how to subtract, he couldn't remember how to multiply and divide. But James, you're not 100% correct. I'll tell you why. Because I have this thing, giving him problems to practice with, right? Because he already knew we were getting there. All of a sudden, one came up with decimals. I said, never mind, we haven't done that yet. He looks, he goes, 0.227. All right, a division problem. So I took my calculator, 0.227. I said, how did you get that? He said, "'Cause heroin is sold by grams and tenths of a gram." He said, "And nobody's ripping me off for one speck in the old days," right? He started to laugh. Okay, but let's say we have kids who are clean, right? There are some kids clearly, right? Clearly, that's not a bad answer, right? I'm glad it got on tape. All right, what else would you do? How else would you decide? Look, this kid, forget it. This kid's okay. This kid's doing quite well, but they can both stay in school. This kid, what kind of test would you have? Go ahead. Name?
Christy,
Go ahead.
you would just do an end-of-the-year test on everything they were supposed to have learned.
Okay. So you do a test on what you were supposed to have learned, and then do what? Okay, that sounds pretty good to me. Go ahead. Then how would I decide that this kid's...
If they didn't remember anything that they learned during the year, then...
Okay, well, how would I know? How would I know? Because not everybody remembers everything. So how would I know that what he has remembered... Tell me your name. His name is not... What's his name?
George.
George. On what basis could I make the decision, listen, George, no point? On what basis could I do that? Okay, so she's got... Wait a minute. So she's got one thing. I'm going to take kids about the same age, right? And then how are you going to decide? Come on, you're there.
Percentage of what they got
Wait,
right.
push it down. You haven't pushed it. Yeah, okay.
Percentage of what they got right and what they got wrong, and above and below a line.
Okay, well, that's one way to do it, to set a line. That's called, here, let me get a new page. That's called, how do I do this? How do I go down? Somebody help me. Never mind. Come on, let's go to the notebook. That's called a Criterion referenced test. Criterion referenced test. I have a certain criterion, and with reference to that criterion, I see whether or not George met the criterion. So everybody else did. Now, it's possible, right, the criterion is, I don't know, 20 questions right. It's possible that someone got 21 right and somebody else got 51 right, but it doesn't matter. They all met the criterion, on they go. But there's another way to do it. There could be another way to do it. Yeah, go ahead.
Compare them to standards? Compare them to the other class? Or
Compare them to?
the other students.
Compared to the other students, right. And that's called, let's go to the PowerPoint. Oh, I did get a new page. That's called a norm reference test. Here, let's go to the overhead for a second, or whatever this is called, the notebook. That's called a norm reference test. So we have criterion referenced. Either you made it or you didn't. So in theory, everyone here could meet the criterion. Oh my God. I'm not so good at using this thing, am I? But a norm reference test says, I'm going to compare you how you did to the norm. What people normally got, to the average, if you will. Okay, come back to me. And if you're and at a certain cutoff point, I'm going to say if you're too far below the average, forget it. You're not benefiting. Okay, let's go to the PowerPoint. And that's, here, you better get my picture out of there for a second. That's the principle of comparison to the norm, or to age norms. Each child's performance on various skill tasks is tested, okay? And then, come back to me, and then I see how you did compared to all the other kids. That is the kind of testing that has pretty much overwhelmed American testing. Interestingly enough, in theory, all the regular tests here, the old Teams test, now the TOS test, now the TACS test, TACI test, what do they call it, the TACI test? All those tests are theoretically criterion referenced. 100% of the people in the state of Texas, the kids in the state of Texas, could pass that test, right? Yeah. Everyone could meet the criterion. Everyone could pass it. I think I'm right. Yeah, I'm right. However, we also have norm referencing there. Well, you had 70% passing, you had 40%, but you had 30%, that kind of stuff. but which it's not supposed to do. But anyway, that's how it works. Theoretically, it's a okay. Now, okay. So we've got the first one down. By the way, the Criterion reference. Whose idea was that? Whose idea was that? The Criterion reference. Tell us your name again.
Hagen.
Megan? Okay. There have been furious battles between Criterion reference people and norm reference people. Okay, those who said, why do you have to guarantee that 25% of the kids are in the lowest 25%? Why do you have to guarantee that 10% of the kids are going to be told you're the worst 10%? Okay? Let's say everybody can succeed. Everybody can get to the criterion. So there's a certain kindness, if you will, in that, a certain sense of what do we care? Let's just, if you've met the standards. The question is what happens when you start saying the be-all and the end-all is the test. But we'll get to that. But that's not what Benet did. He did a norm reference test. Okay, so now we have our strategy. Now the question is, what do we ask on the test? What do we ask? So you're here, and you're going to decide whether or not kids can benefit from school or schooling. So what kind of questions would you ask? Questions about what? Off the top of your heads, come on. Concepts. Push it down, push it down.
Concepts.
What kind of concepts in what?
In front of, behind, next, before, after.
Okay, so certain concepts of language, language abilities, obviously, right? Anything else that you might ask? Somebody already said it. Who was the one who did the norm reference test? All right, what would you ask on that? What she said, tell me your name again? Roz. What Roz said is, who was the one who said I'd see what they learned in school? No, somebody said that. Tell me your name again, I don't remember. Christy? Christy said I'd see what they learn in school. School stuff. So what else is school stuff? I compare how they learned in school. What else is school stuff?
Math, writing.
Math. What? Push it down. What?
History.
Yeah. Questions about history. Stuff like that. I'll say, obviously, I'm not going to ask them, okay? I'm not going to ask them, probably not going to ask them, to explain to, well, what's the arrangement of the furniture in their house. Okay. I'm probably not going to ask them questions about baseball, especially in France where they didn't play it at the time, but, right? There are also certain things that I'm not going to ask them we consider very important. What are certain things that are considered important in society that we really have, we may teach them in school, but we don't consider them very important? What do most of you do? How many people listen to the radio when they're driving in here to take this class so early in the morning? Okay? What do you listen to? What do you listen to? Music.
What station are you listening to? They don't play music in the morning.
Sure they do. The oldies. How many people listen to music on the radio? Raise your hand. Okay, almost everybody. You don't listen to music? We'll push it down. Push it down.
Not on the radio.
I know why. Because the quality's so bad, right?
Yes.
The minute I saw his face, I knew he was a music freak. How do you listen to the radio, to music?
CDs.
CDs. And you have $20 speakers, right?
Yes.
Do you really? No kidding. Okay. See this? I have a friend that when CDs went away, he almost had almost had a nervous breakdown. He paid half a year's salary for his turntable for his records, right? Light balance and what to do and a millionth of a whatever of pressure. Unbelievable. So anyway, so music. Nobody cares. Yeah, they have music in school, but nobody said, well, you're a musical. How many people, if I were to give you a test on either your understanding of music, your ability to play music, or to sing, would get an F-? Right? A lot of people, right? I'd get a C- in singing. I'm going to sing. Heck with it. So, how many people cannot play a musical instrument? Gee, about half. Okay. What else? How many people art? How many people can draw a picture of the person next to you so that we'll know who that person is? No kidding, 4 or 5 people. Wow, that's a lot. Good for you. Okay. Nobody flunks out of nobody will say, oh, this person has a terrible, terrible disability. The person has dystonia or dysdrausia. We don't care that much. Because in school it's music. So that's stuff you didn't find on Binet's tests. So what he did is he kind of cooked them up. And he, by the way, had, although he compared kids to kids of their own age, he basically had a criterion. What he did is he said, look, for each age group, I'm going to have a cutoff. Okay? So I'm going to compare you to other kids your age, but I'm going to have a cutoff. If you're below the cutoff, the way George is, I'm going to say, forget it. Right? Forget it. He's below the cutoff. And even though, go ahead, tell me your name.
Shiva.
Again?
Shiva.
Shiva.
Yeah.
Even though Shiva did better than George, she's still below the cutoff. So I say, forget it. And then, tell me your name.
Katie.
Katie? Mm-hmm. Katie she was tops. She answered almost every question right. And, tell me your name. Lynn. Push it down.
Lynn?
Lynn. Lynn got one more right than the cutoff. My cutoff was 20. She got 21. They're both in. George got 4 and Shiva got 17. Doesn't matter, they're both out. Okay? It was a cutoff, right? Okay. But, so Binet began to take kids of all ages and ask them questions. And then he came up with a strategy, or soon after people developed these tests, came up with a strategy, said, you know what? I'm not going to develop different questions for different ages. I'm going to ask the same questions across different age groups. Right? Why not? So my cutoff for 6-year-olds will be 20 right. My cutoff for 8-year-olds will be 40 right. My cutoff for 16-year-olds will be 160 right. What's the difference, right? Then I have to make a bunch of questions. But I've got to know what the norm is, what the average is. And let's say he made a norm. I really don't know what he did. Let's say you're in the bottom 10%. If you're in the bottom 10%, I'm going to take the bottom 10% and make that the cutoff point. The bottom 10% got below 20 at age 6. The bottom 10% got below 50 at age 9. If you're below that, forget it. So he's got to go and he's got to test all these kids and figure out what the bottom 10% is, right? How many they got? The average was right. Who wasn't? He's got to do a lot of work. And this was the beginning of the 20th century, and this fascinated people. This was the first time really that there was a lot of money to gather consistent data on children across age groups and to analyze them. Them, the word them refers to data. Data, plural. Datum, data. We talked about that, right? Okay. This was the first time to collect systematic data on kids, systematic finding across various age groups, and have the money to do it. You can see that it costs a lot of money. And wow, did that intrigue people. And people from all over the world came to help Binet. And there are two people, or a person, a group of people who came, who really made this great divide in society. One person who came was a man named, a young Swiss biologist named Jean Piaget. Jean Piaget. Okay? And there was another group of psychologists from America who came from Stanford University. And this was the Great Divide, okay? The Stanford University people, okay, come back to me. The Stanford University people said, you know what? we're not going to just be satisfied with having a cutoff point. They went back to Stanford, took the data, said, we can compare everyone to everyone else, right? We can see how far or above or below the mean you are. Then I can differentiate Shiva from George. She's clearly higher than he is. And I can differentiate Lynn from
Katie.
Lynn from Katie. As a matter of fact, Shiva got 17 right, Katie got 21 right, Lynn got 21 right, and Katie got 62 right. Obviously, those two are much closer, and Katie's way at the top, right? I can compare everyone to everyone else in my norm referenced, okay, with my norm references. Okay, I can compare everyone to everyone else. I can put people on a curve of comparison. How we did it, we'll see. Let's go back to the tablet. And Piaget did something else. Okay, Piaget said, wait a minute, come back to me for a second. Piaget, who was given the job of adding up all these answers, and, you know, even though, yeah, he already had a doctorate in biology, he said, we'll see later when we talk about Piaget, the biological rules. He was given the job of adding up for each age how many he got right and how many got wrong and what percentage got this number right and what percentage got this number wrong. But he began to look at the answers. And he took a look and he said, how do these kids, especially the younger ones, come up with such cockeyed screwball answers? Now, those probably weren't the exact words he used, but you get the point. He looked and he said, what is going on here? Okay, and he could, by the way, he could read the original answer, was just right or wrong, because he spoke French from sort of French-speaking part of Switzerland. He said, how in the world can a kid not understand that a mother has to be older than a child? How can a kid not understand that 5 is more than 4? He looked at the answers, he said, something is screwy here. I'm getting consistently wrong answers to certain questions in this age group. They're consistently giving the wrong answer. And it's a ridiculous answer. And he said the fact that it's consistent, the fact that everyone's getting it wrong, and the fact that it's consistently wrong, I'm going to spend a little bit of my career, even though I'm a biologist, and he just had a little interest in this. He had finished his doctorate when he was 19, the guy was. To say Piaget is a genius is like saying the Pacific Ocean is damp, okay? He said, I'm going to spend a little bit of my career trying to figure out the nature of kids' thinking and learning. He once said, I took this diversion in my career and it lasted 60 years, right? So that's exactly what happened, okay? So he went, rather than saying, I'm going to take these questions that basically were cooked up off the top of Benet's head the way you cooked them up off the top of your heads, right? You just did the same thing he did. You got a lot of the same category. There were a few other things he looked at because he was worrying about engineering, so space patterns and stuff, we'll see those. He said, I've got to go and find out what's going on. What's the nature of kids' thinking? How do they come to these weird answers? Later, other psychologists said, why is it that some kids are so effective at learning and other kids are not? Is there a way I can increase their learning? Is there a way I can make kids better able to absorb materials? Okay. Is there a way that I can determine what a kid should be learning and should not be learning? What is appropriate for children at given ages to be learning? And by the way, there are big differences on this. What should I do when a child is having trouble learning? I'll give you a little hint to that. How many people would say, when you're trying to teach a child something, a concept or an idea or a skill, if the kid is having trouble, you should design a program. Your first instinct is to say, let's design a program that will be a remedial program to show the kids how to learn it. And let's do an intensive remediation. How many people have that, think that that's probably a good way to go? You ever think you're trying to... How many people don't trust me, so you're not voting, right? That's everybody, right? It's only a few classes you don't trust. How many people would say, let me design a remediation? How many people would say that that's probably a good idea? Come on, you have to vote. Okay? And how many people would say, that's not a good idea? I probably should, right? Who would say that's not a good idea? Now we're going to do it again. Everybody's voting. Who say, if a kid doesn't know something, I should devise some program to remediate it? Your first instinct is to do that. Okay, that's the majority. How many people would say no? I say no. What's your first instinct? Go ahead. Was there a hand up here? I saw a hand here. I don't know. Who else said no? Okay, go ahead. Wait. Forgot her name already. Lynn. Why would you say no?
Because you'd be revising everyone, and you'd be writing programs for every child in the class.
No, but this is a kid who's really got troubles. Or you're the private tutor. You're the private tutor. I've done a lot of private work with kids. Yeah, go ahead.
Could it be the way you're teaching it to make sure it's the right way to teach them for that level?
Could be to find a new way to teach it, right? My first instinct is to stop doing it. Is to say, maybe this kid just isn't developmentally ready. Maybe the kid just doesn't understand this yet. First thing I got to do is check and see whether what I'm trying to teach the kid is capable of learning. Maybe we just have to wait. That comes from my theory. By the way, those of you who said let's remediate, that's fine. Comes from a different theory. It's not one that I happen to be in love with, but that's all right. So over the years, Piaget developed his own theory. A lot of different theories of how kids think and learn and come to understand and know and develop have come about. But this other track that says, I'm not really interested in that. I'm just interested in measuring is around too. And it has overwhelmed our children. How many people here took the TOS test or the tax test? How many of you felt this is really a good measure of what, it was almost everybody, by the way. How many of you felt this is a really good measure of what I know and have learned? One person. Two people. Okay? What are we doing it for? How many people felt you could learn how to pass this test and not know one damn thing? Right? Almost everybody. So, you know, and so the question is, why are those questions on the test? Why are they there? What's going on here? And this has been going on for a long time. And I will tell you this whole question of standardized testing, I believe, has done unbelievable damage to our children. Right? It is behind most of the labels we have in school. Retarded, slow learner, learning disabled, dyslexic, dysgraphic, I don't know, whatever you have. What else do we have? Dyscalculia, what? What do you have? Go ahead. We may be in for some money here. Did you make one up? Dishonest, right? No, that doesn't. All right. So let me show you now, originally, let's go back to the PowerPoint, how the IQ test first worked, okay? Okay, a child IQ then, by the way, in case you're interested, we're going to start with IQ tests. Come back to the tablet. Come back to the tablet if you can. Stanford University used Binet's work in order to develop the first IQ test. And the name of the first IQ test was? How do I get a new page here? I did it. There we go. The name of the first IQ test was, and it's still in use today, revised numerous times, the Stanford Binet. That is probably still the second most commonly used IQ test. The most commonly used IQ test is the Wechsler's. The Wechsler, which we're going to go over in class. But they went back and made the first IQ test of comparing everyone to everyone else. Okay? the Stanford Binet. And to this day, almost all Piagetians have no use for the Stanford Binet, and many other theoreticians don't either. Okay, let's go back to the PowerPoint. Keep you busy back there, huh? Okay. A child's IQ is determined then by comparing the number of answers he or she got correct on the test. That's not a proper use of the word got, but never mind. To the average number of correct answers for her or his age. See, he, she, I just do it in alphabetical order, and it comes out all even. Okay, so the question is, how is IQ score calculated? Here's the original formula. Okay, you got it? Here, I'll show you. IQ is intelligence quotient. It was called intelligence quotient. CA is the person's actual age, stands for chronological age. CA stands for chronological age. You see the CA there? It stands for chronological age. MA stands for mental age, stands for mental age. Okay? So it's your mental age divided by your chronological age times 100. Okay? And this is the score at which the person's score was the average number. This is the age at which the person's score was the average number correct. Now you understand it? Probably not. Okay? Because I'll explain it to you. If you do, you're pretty good. Okay. Come back to me for a second. Okay. When you have a addition problem, the answer is called the 3 and 3 is 6. 6 is the sum. When you have a division, 6 minus 4 is 2. 2 is the what? 6 minus 2? The remainder. Right? 3 times 3 is 9. 9 is the product. And 8 divided by 4 is 2. 2 is the quotient, right? The quotient is an answer. Go back to the PowerPoint, right? A quotient, that's why it's called an intelligence quotient, because you have division here. Okay, so let me show you how this works. Okay, let me show you how this works. See if I can get a new page. There we go. Nope. What do I do to get a new page? Push this and hit this? Tell me what I do to get a new page. Scott, tell me, help! Don't I just hit this? What? Here, right? But I can't get it. What? There we go. All right. So, here, let's put the formula up here. IQ equals mental age over chronological age times 100. Okay? So your chronological age we know. Okay? The mental age is, as we said, the age at which the person's score was the average correct number. So let's say 7-year-olds got an average of 52 right. And a child gets 52 right. What's the child's mental age? 7, right? Let's say 8-year-olds get an average of 83 right. Okay? On the test, on these questions. So if you got 83 right, your mental age is 8. Okay? And let's say, let's skip to 9-year-olds got an average of 103 right. 9-year-olds got an average of 103 right. And 10-year-olds got an average of 145 right. So let's take a kid. What's today? We went about the he, she's. We already went through that, didn't we? Today's a he day, and I'm doing it. So let's take a kid. Today's a he day. I don't know. Let's take John. Okay? Okay. John is 7 years old. Okay? That's his chronological age. I'm going to take this formula, right, and stick it down here. He's 7 years old, right? What's his mental age if he got 52 right? 7. So 7 divided by 7, let me count my fingers. 1 times 100, anybody have a calculator? Is 100. So is 100. So his mental age is the same as his chronological age. Okay? It's 100. So 100 is the average IQ. Now let's say he got 53 right. So this would be, I don't know, his mental age, they had it would be 7.1. And his IQ would come out 101 or something like that. I don't know. You understand what I'm saying? It doesn't have to be exact. If he got 103 right, okay, his mental age is 7, what would his mental age be? His chronological age is 7, right? What would his mental age be? 9. Who has a calculator? So 7 divided by 9 is? 9 divided by 7 is? Oh, here's somebody with a calculator. Bless you. 9 divided by 7 is?
1.2.
Push it down, push it down.
1.29.
1.29. 1.29. 1.29. Let's start again. Is 1.29 times 100 is 129, right? Times 100 is 129. So his IQ would be 129. You get it? You understand what we're saying? That's how it was done. Okay? So, now if you have a kid whose chronological age is 5 and whose mental age is 10, got as many right as the average 10-year-old, this comes out to 2 times 100 as an IQ of 200. You get it? Let's take Bob. Okay, let's say the average, Bob is 12. Okay, the average number that 12-year-olds got right was 87. The average number that 11-year-olds got right was 187, was 162, and the average number that 10-year-olds got right was 140. Okay, now Bob is 12. Bob is 12. Okay? He got 140 right. So what's his mental age? 10. How much is 10 divided by 12? You put it away? She put it away. All right. 10 divided by 12 is? Push it down. What do you get?
0.83.
0.83. You did that in your head? Oh, you have a calculator too. 0.83 times 100 is 83. So he has an IQ of 83. You see what I'm saying? This is how it was done. Okay. That was your intelligence quotient. Okay, come back to me now. But there was a problem with this. There were a couple problems with this he didn't like. Problem number one was that it began to get harder and harder to distinguish 19-year-olds from 20-year-olds from 21-year-olds. Then this became a big business. You go into adults. Well, how are you going to distinguish a 52-year-old from a 57-year-old? Begin to get a little weird. Let me tell you something, by the way, a general principle. When things are done for kids, when you have something that's laid on the school system and it makes big money, okay, makes big money, pretty soon it goes to adults. Somewhere around are lying the first tapes I ever made for this course. And I said there, ADD is such a... At that time, people were saying, ADD afflicts children. It's a disease that children get, and then it goes away in adulthood. That was the party line. I said, this thing is such a big business. It's making so much money. I guarantee you that before you know it, there'll be adult ADD, and people will make money from that. Was I right? It's so hard to be right all the time. You know, it's a big burden in life. Okay, I'm just kidding. The other problem was that it tended to be, here, let's go back to the tablet if I can get there. Get your calculators ready. I did it so nicely the last time. Here? Oh, thank you. Oh, yeah, there's okay, let's say you have a kid who's always staying 1 year ahead of his or her class. So if the kid has a mental age of 5 and a chronological age of 4, that comes out 4 divided by 5 is 1. 1 and a fourth, right? 1.25, have an IQ of 125. Next year, the kid is still ahead. The kid has a mental age of 6 and is 5. What's 6 divided by 5?
1.2.
1.2? 1.2 times 100, the kid's IQ is 120. Let's go to 10. The kid's still a year ahead. The kid's 9, has an IQ of 10. It's 1.11. It's 111. You know how I did that? 1/9 is 0.11111. 2/9 is 0.22222. 3/9 is 0.33333. Who knew that? Who didn't? See that? 3/9 is 1/3, right? 8/9 is 0.8888, and 9/9 is 0.999, approaching 1, okay? Believe me, I was older than all of you when I learned that. It wasn't so long ago, okay? So you see what happens. As you stay ahead, your IQ goes down, so they didn't like this. On top of that, okay, so they said, this is not good. This is distorting. So they came up with, come back to me now. They came up with a formula, okay? They came up with a formula. Let's go back to the PowerPoint. Today, this traditional means of IQ calculation is abandoned in favor of using standardized scores based on the use of standard deviations. Okay? Standard deviations. Now, I'm going to tell you what a standard deviation is. Come back to me so you'll get the point. This was developed after the Stanford-Binet came in, and it was used as a different method to compare. Okay? Look. Mathematicians, statisticians began to realize early that there were ways to summarize groups, and that's what you're trying to do here. So if I want to say to you, okay, I have a, let's do something I really did, a seventh grade history teacher. Okay? I used to be one of those. Okay? And we have, anybody's here named Green? Anybody here have a last name Green? Anybody here have a last name Brown? All right, if those who are watching the tape, I apologize, it's nothing personal. How did Mr. Green's class compare to Mr. Brown's class on the history test? So you say, well, here are the grades of Mr. Green's class, 82, 74, 36, 89, 100, 96. Here are the grades of Mr. Brown's class, 47, 100, 100, 98, 64, 62. Nobody does that. What do you do? How do you compare Mr. Green's class to Mr. Brown's class? How would you do it? Push it down. Oh, George, look at, he's got the little section.
Class average.
What? Say?
Class average.
Class average. You're saying, oh, the class average in Mr. Green's class was 72, and in Mr. Brown's class it was 43. You say, you know what? This class did better than that class. Now, I know very well. Let's say it was 72 and 85. Now, I know so I'd say Mr. Brown's class did better than Mr. Green's class. Now, I know very well that it's quite possible, even likely, that the worst mark in the class with the highest average was lower than the best mark in the class with a lower average, but I'm summarizing. And this is how we would do. People would summarize, okay? So you know very well, if the average income in the United States is, for a family of 4, is $42,000 a year, and the average income in another country is $12,000 a year, you know that the people in the United States are much better off. That's not to say there aren't people in the United States who live in poverty, and there could be multimillionaires in the other country. As a matter of fact, in most countries that have average incomes that low, there are a lot of people who are filthy rich, okay, millionaires. But you get an idea, okay? And this went on for a long time, but then something happened. People began to realize that an average can distort things. Or as a statistician friend of mine once told me, he said, I turned the stove on. He said, I stick my feet in the stove, but don't worry, I stick my head in the freezer. On the average, I'm okay. All right? You get the point? Okay. So I'll give you an example. I believe that the average high temperature in Amarillo, Texas, if you take the average high across the year, 365 days a year, 66 something period, and compared to the average high temperature in Seattle, it's roughly the same. Pretty close. No, I've been to Seattle a few times. Anybody been, aside from the fact that it rains all the time. Okay? Seattle has a pretty temperate climate. It's always somewhere around the average. Okay? Anybody ever been to Amarillo in the summer? Who's been to Amarillo in the summer? Who's from Amarillo? You're from Amarillo? Push it. Go ahead.
I'm from Borger, Texas, which is north of Amarillo.
Yeah, how are the summers there? Hot. What? Hot.
Summers are hot, dry.
Get over 100?
Sometimes.
Sometimes. How are the winters? Push it down.
Very cold.
Snow?
Sometimes.
Yeah. You've been to Amarillo? You know what I'm talking about. In the winter or the summer? Push it down.
Both have family down there.
Did you live there? No. So, he said no, but it's bad, right? My daughter went to do got a job in Denver, so he said, she got a lot of stuff, we'll drive her up. So my wife is driving her up, and we go to AAA, and they track us out a nice path, and it's up through Kansas and over. She was going in December. Got the job in December. So I look on the map. I said, what are you talking about? You can go right up, through Wichita Falls. It's, it's much shorter. But it's shorter provided you're not snowed in at Amarillo. There's a pass there that gets snowed in. You get snowed, you got to turn around, come back the other way, right? The summers, and I was in Amarillo once in the summer. It's dry, but it's hot. It's like someone's got a hairdryer blowing it in your face. Am I right? Yeah, he's going like this, yeah. It's unbelievably hot, right? And you take 4 steps and you say, I'm going to die of thirst, right? Because it's just, because it's dry, so the water's evaporating out of your body, and it's just, you don't feel thirst, right? And the winters are cold. I never went there in the winter. I learned better after that. Cold. So if you average 100, 0, and 50, you get 50. You average 50, 50, and 50, you get 50. You get the point? Okay? In Seattle, it's never very hot or very cold. And Amarillo, you get extremes of hot and extremes of cold. Right? And you get the same average. Now, this makes a difference. If you're a farmer in Washington State, outside of Seattle, and you decide you're going to move to around Amarillo, and people tell you, well, the average temperature is about the same. And you're going to use farming techniques that you try to use in Seattle and Amarillo, you're going to go broke fast, right? By the way, and the same thing applies to education. If I say, let's say I came out that Mr. Brown's class and Mr. Green's class both had the same average. They both got 72 on the test. Okay? That's not the greatest. I'd rather have the average 10 points higher if I could, right? So I say, okay, here's a remediation plan, but here's Mr. Brown's class. Here are the grades of Mr. Brown's class. 72, 73, 75, 70, 71, 73, 72, 74, 73, 72, 70, 76, right? Came out to, what did I say, 72, right? Somebody's going to be on the tape and count it up. I'm just making an example, right? And here are the grades. That was Mr. Brown's class. And Mr. Green's class, 37, 98, 82, 76, 44, 100, 53, 89, 47, 92, 63, 22, 107 extra credit, right? Average out to 72. Well, if I'm the teacher, if I'm Mr. Brown, I got one job. I've got a whole class about the same. I'm going to pull them up together. If I'm Mr. Green, I have a very different job. I have some kids who are very strong and some who are very weak and some in the middle. And I've got a whole different set of problems facing me than if I have one class and everybody's about the same. In the first case, I might say, well, Mr. Lieberman's class, I might say, you know what, these kids are all about the same level. Maybe I got to have a compromise between trying to get them ways to learn a little better, and maybe I got to back off a tad, because obviously it's too hard for them. Almost nobody's getting A's. The other class, I don't know what to do. Some of the kids are getting everything. Some of the kids are getting nothing. Kids are in the middle. I do have some ideas what we're talking about, but it's a very different problem. Okay, so somebody came up with a measurement. Let's go back to the PowerPoint. called a standard deviation to account for that. To account for that. Okay? And I'm going to show you here. Okay, you don't have to remember this, and I'm not going to go into it in detail. Now I got a calendar up here. Okay, let's go back to this tablet. Okay? I keep getting a calendar. Where do I push? There we go. Okay, look at this is the formula. Sigma means add together. Add together. Okay, N equals the number of scores. And X equals an individual score. So what is this? Sigma X over N. What is that? Anybody know? Say it again. Push it down.
The average.
Average. That's the average. How many people got confused by that the first time you saw it? My hand's up. All right. So how did you know it right? Oh, you knew already. Go ahead. How'd you know?
I'm in statistics right now.
Oh, it's taking statistics scores, right? You've been doing this since 5th grade. Add up the scores and divide by the number of scores. Okay? By the way, there was a, come back to me for a second. There was a physics professor on campus. I used to do some work with him. And he gave people the following test. John is taller than Mary. Mary's taller than Joe. What's the relationship between John and Joe? Then he said A is bigger than B, B is bigger than C. Then he used A. Then he used A with a greater here. Then he did this one. Come up back here. He did A is greater than B, and B is greater than C. And he went through the whole test. Come back to me now. Doing the whole thing with words versus mathematical notations. Every question was exactly parallel. And he gave the test to the same people. The score was 20% higher on the word test than on the mathematical symbols test. The first one he had averages was in the 90s, and the other one was in the 70s. Unbelievable. But this, so let's go back here. This is what you've been doing, and this is called a mean. Okay? And that's the arithmetic average. Is that how you spell arithmetic? Doesn't look good. Is that how you spell arithmetic? What? Is that it? I got to find out. Don't do anything here. Okay? I got to find out. That's what you do. When you don't know, you should find out. How do I get a... wait a second. I'm going to get a Word document here. How do I get a Word document out of this thing? I don't know. Is that it? Tunes, show desktop. Where do I get a Word document? Help me here. Oh, I'm going to make me do this? Come on, start, and then programs, Microsoft Word. All right. Can you get this on the screen, or it has to be PowerPoint? Oh, my God. Oh, no, I hit the wrong thing. Forget it. Come back to me. Come back to me. Okay. So the mean is the arithmetic average. Yeah. And it's the mean is the arithmetic average. And what it does, I messed up this computer so badly. Okay. Arithmetic. That's right. Let's put the E in. Likes that one too. Forget it. I hate computers. All right. Okay. So, okay, come back to me. So if we have the, and I don't know where my documents are. So if we have the arithmetic average, here we go. Don't worry. All right. Help me here. I don't know where my PowerPoint is. Scott, help me. Okay. So if I have the arithmetic average, that's only one kind of average. What they said is, let's also take an average Let's also take an average. Oh, never mind. I got it. Let's also take an average. This is great television. That's why I do it. Keep things popping. Come on, will ya? Hit the wrong button and you wind up. One time, there used to be a search engine called Lycos. So the guy says to me, the first person ever taught to me, teach me how to use the internet and the web. He said, just type in Lycos, right? And then you'll get the idea. They'll take you through it. So I type in Lycos, and this unbelievable porn comes pouring out of the screen at me. I sort of went like this. You know, I said, my God, get rid of that. Do it again. I'm spelling Lycos with a K. I went to him, I said, all I'm getting is this offensive porn site. Right? And I was younger then. I still found it terribly offensive. He said to me, no, he said, do it with a C. Oh, okay. Then I went to I found it with a C, but it's just. By the way, you will notice that many sites, never mind. Many sites, if you make a little spelling error, or if it's instead of, I don't know if it's this one, but instead of Congress, you know, you put Congress 1. If that's the website of Congress, you just put Congress, out comes porn, or out comes, it's everywhere. Anyway, it's just, all right. So that's, by the way, this is called, let's go to the tab, this is called a mean. The reason this is called a mean is because there are other kinds of averages, not just arithmetic averages. Okay? And that's what a standard deviation is. What they said is, look, let's take every score and subtract it from the mean, and then take the average of that. Okay? That's a standard deviation. Not quite, though. Okay? That's what they said. Let's subtract every score from the mean, right? Okay, so come back to me, and then add them all up. So you can see. So in the first class, I guess in Mr. Brown's class, right, the mean is 72, and I've got 73, 74, 76, 77. I'm going to get 5, 6 points, right, when I subtract. And I added all of those up. The other class got a 72, and here's a score of 100. It's 30. Here's a score of 12. It's 50, right, 60. I'm adding all of those up. See what I'm saying? I'm adding up how far your score is from the average, from the arithmetic average, from the mean, and taking that average. And that's big. The only problem is, I kind of lied to you. It's not really true. Because, let's say, let's take 2 different people. Tell me your name. Tisha. Push it down.
Tisha.
Let's say Tisha got a 73. Okay, and push it down, push it down.
Allison.
Allison got a 71. So I'm subtracting each score from the mean. So this mean is 72. Tisha got a 73. So 72 minus 73 is -1, right? And Allison, right? She got a 71. 72 minus 71 is +1. I add -1 and +1 together, and I get a big fat 0, right? The pluses cancel out the minuses. See what I'm saying? As a matter of fact, that is exactly true with the average. If you take every score, subtract it from the average, and add them up, you'll get a big fat 0. Okay? So what they said was, well, we got to do something about that. So they could have used, they decided to use, I can't remember what you call it here. Come over here. What do you call this? Absolute values. They said, come back to me. They said we can use absolute values. But in the end, I'm sorry. Let's go back here. They decided to square each number. So you square the 1, you get a 1. You square the -1, you get a 1. If somebody got 5 points below, that person, you take that +5 and square it. And a -5, you square it, and you get a +25. Okay? Here, so you have to square each score. So here, let's go back here. You don't have to remember this, but the idea was, I'll just tell you briefly. You take each score, subtract it from the mean, and then whatever you get, you square it. So if somebody's score was 10 points above the mean, so you take a 72 minus 82 is a -10, you square it, you get 100, right? A +100. If someone's score was 10 points below the mean, person got a 62 is a +10. 72 minus 62 is a +10, you square it, you get a +100. Okay, you add all those up, okay? Come over here, then you divide by the number of scores. If you're taking a sample, it's n minus 1, don't worry about it. And this is called the variance. This is called the variance. It's a huge number because you're squaring 100, 200, you're squaring big numbers and adding them up. Then somebody else said, you know what, since you squared every score, take the standard deviation. So if your variance comes out to be 121, take the square root of it and you'll get 11. Take the square root back, okay? And that's the standard deviation. How many people understood what I just did? A few people. How many people understood what I just did and have never taken a statistics course? Nobody. Okay. Come back to me. Here's the point. The point is that what we do is to say, I'm going to take the average, and then I'm going to get an estimate of how far scores deviate from the average. Right? So if I took, and I call it a standard deviation, but the average amount, because it's standard, because it's the average amount scores deviate. If I took the standard deviation of the high temperatures in Seattle from the average, it would be very small. Right? If I took an Amarillo, it would be very big, because I'm getting, it goes down to 0 in Amarillo, doesn't it? Yeah, it gets cold there. It never gets that cold in Seattle, and it never goes up to 100. It never gets, I won't say never, but virtually never. So then, what I'm able to do, if I can get back to the PowerPoint, what I'm able to do then, okay? So then, I'm going to use those statistics to figure out a person's IQ. Okay? To figure out a person's IQ, how to get a normal distribution. I got to show you something here. Okay? Here's, how close can you get to that? I have tried 18 different ways as a best. Can you get closer to this? Can you get that bigger? Is that the closest you can get? All right. This is what, something happened, okay? Something happened, and we'll go into this next time, but I want to start now. When people began to do this IQ and standard deviation stuff, when they began to do mean and deviation, they found out that there was a set pattern to the distribution of the scores, provided you had this, what we call this bell curve, or a normal curve, or a normal distribution. Okay? You understand that? How many people have never heard about this bell curve or normal distribution before? You've all heard of it? Good. Okay? Come back to me for a second. The normal a lot of things distribute normally. If I take, how many people ever played baseball or softball? Who played the outfield? Who never played, hated the sport, and couldn't play it worth a damn? Let me take another female. Okay. Come up here. Okay. Now we're going to do some. Okay. I'm going to get, wait a second. Roughly how far can you throw it? What is it, softball or baseball? Softball? Roughly how far can you throw a softball?
From the outfield?
Yeah, if I would tell you, heave it as far as you can. How far do you think you could get?
Shortstop.
So how many feet do you think that is? 150 feet? 150 feet? Let's say it's 150 feet, okay? That sounds about right. Softball's harder to throw than baseball. And how far do you think you can throw?
I couldn't guess. I don't know.
Let's say 50 feet. Sound like reasonable or an overestimate? Right? Okay. So I'm going to get, let's get their names. Alexis and?
Jennifer.
And Jennifer. I'm going to get Alexis and Jennifer up each day, and I'm going to say, before, okay, you're going to get your car in the morning, and before you go wherever you're going, we're going to drive to a field, and you're going to throw a softball, as far as you can. Okay? I'm going to take out days when they're sick, or if one breaks an arm or something. I'm going to throw it as far as you can. Okay? And I'm going to get an average of 50 feet for Alexis and 150 for Jennifer. But if I measure each day the scores, go back to the overhead, okay? Go back to the PowerPoint. The scores are going to distribute normally, like on that PowerPoint, okay? I'm going to get from, okay? So what I'll get, let's try this, okay? Let's try this. Here, let's go to the tablet, if I can get one here. Well, I'll do it from here. Jennifer's scores will distribute like this, with the average being 150 feet. And Alexis scores will distribute like this, with the average being 50 feet. So, here. Why can't I get another one to come? Okay, let's go to the tablet for 1 second. Okay? This is 150 feet over here, and this is 50 feet over here, and this is the number of times you threw the ball. Okay, this is what Alexis is going to look like, and this is what Jennifer is going to look like. Okay? Most of the scores are going to be at the average. The farther away you get from the average, the less times you have it thrown. Okay? Someday you have a good day, someday you have a bad day, but they're both going to distribute normally, almost for sure. Okay? Come back to me. And once, okay? So it doesn't matter. If I were to take the height of all the men in the United States, it would distribute normally. Okay? Then if I were to take the height of all the basketball players in the United States, it would probably distribute normally. The first one would have an average of probably 5'8". Second would have an average of 6'6", but it would distribute normally. And what happens when you get a normal distribution with standard deviations is the key to standardized tests. We'll talk about that next week, next time.